Hello everyone. So in this video we are going to do edge detection. So first we will understand what is convolution. So first of all let us understand a kernel matrix. So we have a matrix which is odd number cross odd number matrix. It is either 3 cross 3 or 5 cross 5 generally, or it might be also 7 cross 7 in some cases. Now we move that kernel over our image. Now we know that our image has three such layers. It is a 3D NumPy array. So it has three such layers of numbers. So what do I mean when I say convolution? I'm convoluting this image with the help of this kernel by moving the kernel over the image one step at a time. So in doing so I am generating another convoluted final image, which is and whose pixel values are obtained by the weighted multiplication of the kernel matrix. So as you see, if this kernel matrix is placed on the top left of this image, so we have 7, 2 and 3 multiplied with 7 into 1 plus 2 into 0 plus 3 into minus 1, and 4 into 1 plus 5 into 0 plus 3 into minus 1. And in this way we can see that 7 minus 3 will be 4, and this is 1 and this is again 1, so we will get 6. 4 plus 1 plus 1, 6. So we'll get 6 in the front pixel. So in this way we do convolution of an image. So what is the use of this? Can you understand this? So it helps us to reduce the number of pixels of an image. And what if all the values were, let's say, 1? What would have happened then? So if you see, we would have got an average value of 9 pixels in every way, in every places. It is equivalent to getting average, right? If we are basically adding all the pixels and then we are putting it in the convoluted final image, so we will basically get a blur image of our initial image. So this way, using a kernel and convolution, I can create a blur image from another image. Similarly, there are some kernels which helps us to find which basically helps us to sharpen an image. And here what I am going to use now is famously known as the 8, minus 1 kernel, which can help to detect edges. So let's say we have a portion of an image which is completely uniform. Let's say all of the pixel values are 20. So what would happen if I apply this kernel over this portion of the image? We will get exactly 0, right? Because all of the minus 1 are there 8 times and all the values of 20 are same, and it will be multiplied and exactly cancelled out. So we will get 0. And similarly, if we have, let's say, an edge over here, what do an edge in an image means? There is sharp change of values of the color of the pixels, right? So here the color of the pixels are 20 and here it is of a different color, so there is an edge over here. So if we get an edge, then we would have a high value. So here we can say that if we move this kernel matrix, if we are convoluting over an image, the portions where there will be low value, those portions are supposed to be uniform, and the portions where there will be high value of convolution, that those portions are supposed to have edges. So in this way this can act as an edge detection kernel. So let us just see how it works. So using PIL, I am just importing the image. So and this is the command argument which I am giving. So this is the correct usage of that argument. So it just helps the user to just understand what is the format of the usage in which I have to enter. And this filter image, let's say I am creating a filtered image in which my kernel matrix is 3, minus 3, 3, and the kernel is of order a minus 1 minus 1 a, and in between it is 8 as I have shown you, and scale is 1. So if I try to show the resultant final image, so let us just execute this program. New terminal. Here the command line argument is there, so I have to do python filter.py, and we have a bridge which is bridge dot png. What would happen if I just execute this program? So I get some edges. So this actual image was something like this, and after I apply the 8, minus 1 kernel, or minus 1,8 kernel I get. So as you can see, this is our output, and it helps us to detect the edges of our original image. So our original image was something like this, which after edge detection became this. So even the very fine edges we are also able to calculate. So there is something better known as Canny's edge detection. So it first blurs an image, so we will learn about that later. So it has an algorithm which follows as something. After first they are blurring the image by a little amount, and then they are detecting the edges, and we can do various types of manipulation using those. So here is a lot of noise also. So if we do here the very fine edge detection is happening, that's why. So we will see about those in our some later videos when we'll talk about some projects. So yeah, that's all from this video.